Good afternoon, Ross Finlayson, December 28th, 2023, Seattle, Washington, USA. Well, here, what we've been talking about is moment and motion. That the moment both reflects the instant of things as they rest and achieve a stasis or in the static, and also as the moment of the lever of things, the lever or lever, the most simple machine with which you describe the axis of a fulcrum and the notion of a mechanical advantage. So the moment is kind of both these things, and that's why it's in this sort of gestalt of how these things come together. We make this deconstructivist account to help relay and entertain the notions of what goes into that. There is essentially a meaning to these methods and a method to these meanings, and particularly that we attach it to the canon and these schools of men and the science and the study and the theory that it's all about foundations. Foundations is our theory, and it's good, formal, and rigorous, and made for the human mind to comprehend as a monistic whole. So, what I have here are some more books, and so what I imagine I would do is just kind of look through what I have collected here and discuss their significance and the meaning of their text. It was discussed here a little bit how important it is that it's matters of the textual, and as insofar as the meaning of the text goes, that it's the written word as much or more than anything else that represents the body of knowledge that makes for humanity the difference between us and a more primitive society, say. And so it's kind of like Carl Sagan said once. He said, the only reason humans are intelligent is because of libraries. So let's see what it is in this time. With respect to David Bohm, I've been reading some more about him since I heard many years ago, about a decade ago at least, about Bohm and de Broglie, and that Bohm had extended de Broglie's works, which is where there was Newton and light as corpuscles, and Huygens and light as waves, and Fresnel as light is definitely waves. And then to Einstein is like, well, in electron physics, where electrons are particles, not waves, also photons are particles, not waves. And then forward to that, then after we get to de Broglie again, after particle wave duality is what the way of the things is according to quantum mechanics with the Pauli exclusion principle and the old quantum mechanics and this Copenhagen statistical interpretation of quantum mechanics and Heisenberg and uncertainty and the introduction of the observation, sampling, observer, and measurement effects, which are with regards usually to interference with the system. And then with regards to also the notions of the, how one might say, carriage forward then is de Broglie's interpretation by Bohm of the analysis of the wave function of the Schrodinger psi, the wave function, and its collapse when it coalesces to an event, this particle, that it is as well, according to Bohm then, to be returned to a form of implicate order, as he puts it. So here's a book by David Bohm, and it's called Wholeness and the Implicate Order. And this copy is from ARC Paperbacks, and it was posthumous to Bohm. And so this says this is first published in 1980, and this edition is from 1983. It's reprinted in 1994. And so then with regards to this, we take a look at it, and what it has is he discussed fragmentation and wholeness. Now, it's interesting to point back to the notion of parts and fragments with regards to a reading of, as from set theory, the notion that the set and the regular and ordinary only makes fragments of this whole, while the whole has its parts. So you have this entire contradistinction between set theory and elt and class theory and membership. And then in the middle, they just have one of these inductive impasses in the middle in with regards to the deductive analysis and the abstraction of the abduction works to bring them together as a comprehensive whole, each defining the other side, each making a place for each other in this way. Combination of science and philosophy. So for Bohm, there's one part to take with him as we talk about like what is retained or what is confiscated from the appropriation of the previous authors in our canon, and is what with regards is good. And so this good thing in Bohm is this notion of the implicate order. And then with respect to some of the other notions that kind of let out the other side, like after the statistical ensemble, there was a multiple worlds hypothesis. And as with regards to how things are and how they may be, there was some notion that it wasn't really a deterministic world. Bohm kind of helps resolve that dilemma, while at the same time then he entertains kind of these wider notions of there's like, well, then signal and information could be omnipresent, or the pseudoscientific, the non-scientific associated with quantum consciousness. That's let aside and kept aside with regards to Bohm's interpretations, while at the same time what we have are the meaningful parts for continuum mechanics. It's a continuum mechanics again. And then we have for Heisenberg, it's just a matter of fact that when we talk about electron physics and the way things are modeled, it's the conceit of the particle zoo of what is our atomic and subatomic physics, and the molecular physics above that as well, after angstroms, and the Planck regime below that as well, and down in much farther to the superstring theory. It's a continuum mechanics. The Rio mode, an experiment with language and thought. An inquiry into our language, the form of the Rio mode, truth and fact in the Rio mode. So rheology is a study, it's kind of like tribology and rheology go together. And so I'll read here a brief definition from Bohm about what that is. Reality and knowledge considered as process. Hidden variables in the quantum theory. Now this, of course, is the primary course of description of what's after the statistical ensemble and the statistical interpretation that are hidden variables. And this is called the non-local part, the extra-local part of what for Einstein, when Einstein wanted to figure out particularly how to connect this bridge between the angular and the linear. So he calls it a bridge, and then he defines it, and afterward it's kind of carried by Podolsky and Rosen out into condensed matter physics with regards to the conceit of the particle and how it coalesces or how it waves, returns to a waving motion, as it were. The Einstein's bridge, though, is really a relation for the classical and for Newton's zeroth laws of kinetics and kinematics. Bohr's resolution of the paradox of Einstein, Rosen, and Podolsky, the indivisibility of all material processes. So this is a key thing for Einstein, is like, it's got to be one differential system. That's one of his significance of what he thinks would be the desiderata and requirements of the theory that is true. So let's take a look here at rheology. The form of the Rio mode, page 32. A suitable form for the expression of the Rio mode. We may ask whether the rich and complex and formal structure of the commonly used language does not contain, even if perhaps only in a rudimentary or germinal form, some feature that can satisfy the need indicated above to call attention to the real function of thought and language. So he says the word relevant derives from a verb to relevate, which has dropped out of common usage, whose meaning is to lift, as in elevate. This is, remember the relevant and keep it relevant. In essence, to relevate means to lift into attention, so that the content thus lifted stands out in relief. This is with regards to like the notion of the form of the multimedia composition of art called bas relief. That which makes, according to perspective and projection and perspective, these things. In making a statement about relevance, one is treating thought and language as realities, as they were. And he says that it only must be an art to figure that out. I disagree at this point. fitting and non-fitting, fragmentation in language, the poetic way, to lift. As a step in developing the Rio mode, we then propose that the verb to levate shall mean the spontaneous and unrestricted act of lifting into attention any content whatsoever, which includes the lifting into attention of the question of whether this content fits a broader context or not, as well as that of lifting into attention the very function of calling attention, which is initiated by the verb itself. This implies an unrestricted breadth and depth of meaning that is not fixed within static limits. It's remarkable the lighting on the camera today. It says with regards to the sky or whatever, as a machine in the media, it's a pretty simple mobile device. One of these all things included portable packet radio cellular devices with a phone on board and a touch screen and what's called a high resolution screen with regards to that its aspect ratio is basically for high definition television and such. So yeah, I hadn't so much adjusted the settings. I'll have to look at it a little bit and see if I did. It's like, do I know where all these things are? It's like, no, I do not. I do not. Finally, we shall introduce the noun form levation, which signifies a sort of generalized and unrestricted totality of acts of lifting into attention. So, about Bohr's resolution of the paradox of Einstein, Rosen, and Podolsky on page 69. From the fact that quantum theory agrees with experiment in so wide a domain, including the problem treated in the previous selection as a special but typical case, it is evident that the indeterministic features of quantum mechanics are in some way a reflection of the real behavior of matter in the atomic and nuclear domains. But here the question arises just how to interpret this indeterminism. Well, how I interpret it is super classical, and it's so there's just the whole notions of superfluidity, superconductivity, that in the real space that the information in the wave and the signal is essentially free. And then as with regards to why then the quantum domain has this with regards to physical interactions of things, vis-a-vis the power of experiment to interfere with it and joggle out a marble, which results something to count when it hits the detector, and the observable of the high energy micro and nanoscopic experimental physics. There's that looking for a cause. We're looking for a causality here with regards to ultimately this first principles and final causes, and the least thereof that we can arrive at. The least action mechanically, the least action mentally. With regards to then the concepts are rich enough, super classical, to support how then it still falls into place naturally. So, to clarify the meaning of this question, we shall consider some analogous problems. Thus, it is well known that insurance companies operate on the basis of certain statistical laws, which predict to a high degree of approximation the mean number of people in a given class of age, height, weight, etc. For this, you can refer to part of the previous discussion on the central limit theorem and the usual foundations of statistics and probability theory, and modern and novel non-standard approaches to the Bayesian, the Jeffreys, the Knightian. Then that with regards to prior probabilities, then there's also regards to uncertainty, various approaches to these things. That then the actuarial tables are as after demographics and the pool with regards to then things like the quantitative analysis thereof. That the actuarial exams are very, very arduous and designed to help establish particularly the correctness of the design of the statistical experiment, because otherwise either people lose money or people die. So. That will die of a certain disease in a specified period of time. They can do this even though they cannot predict the precise time of death of an individual policyholder, and even though such individual deaths are distributed at random. So I wouldn't want to read too much into this example, that nevertheless, the fact that statistical laws of this kind are operating does not prevent the simultaneous operation of individual laws, which determine in more detail the precise conditions of each, for when the same result can be produced by a large number of essentially independent events. The importance of such considerations is quite evident. Statistics will lie if you let them. Thus, in the field of medical research, the operation of statistical laws is never regarded as a reason against the search for more detailed individual laws, e.g. as to what makes a given individual. Similarly, in the field of physics, when it was discovered that spores and smoke particles suffer a random movement obeying certain statistical laws, the Brownian motion, it was supposed that this was due to impacts from myriads of molecules obeying deeper individual laws. So here it says as of the fall gravity and asymptotic freedom, and then with the charge and kinetic in the very small, with regards to what's kind of built up as this tetrad of charge and mass and proton lifetime and light speed. It was supposed the statistical laws were then seen to be consistent with the possibility of deeper individual laws. Hidden variables must be. Es muss sein. Or to put the case more generally, lawlessness of individual behavior in the context of a given statistical law is in general consistent with the notion of more detailed individual laws applying in a broader context. So how we interpret probabilities as a law of large numbers, because the sample is random and it comes from an unknown distribution which has its hidden variables. If you perfectly know the distribution, you can perfectly estimate and guess. But there's no real prediction of the things. There's just that it happens that an estimate was some prediction and it matches. The law of least surprise, as it were. For something like what you could consider as the laws of large numbers, then, is that there are a variety of them. And in rules of convergence for infinite series, we have interesting details considering the convergence and the uniform convergence of these things. And indeed, various systems of numbers and equations in series that do and don't have what apply these kinds of things. I feel quite washed out from the way the screen is, but hopefully it'll still be decent audio-wise. These factors would be represented mathematically. Of course they are. Mathematics is ubiquitously successful in mathematical physics. It's the model. Subquantum relativity sense. At this, so I'm trying to see what he has to say about Einstein-Podolsky-Rosen, which is two things. It's the bridge to condensed matter physics, and it's the bridge of Newton's zeroth laws. All individual laws, e.g. classical mechanics. Not here. Here we have a theory of sum and theory of omega potentials. Classical mechanics is just the random draw in the middle that happens to follow these laws of large numbers. Are then regarded as limiting cases of the probability laws for systems involving large numbers of molecules. So then Bohm helps explain some of these kinds of things. So carrying forward, now we have Bohr's resolution of the paradox of Einstein, Rosen, and Podolsky. It's actually on page 73. The indivisibility of all material processes. The paradox of Einstein, Rosen, and Podolsky was resolved by Niels Bohr in a way that retained the notion of indeterminism in quantum theory as a kind of irreducible lawlessness in nature. So we might think of Born and the restless universe. The very idea that at some level our smooth continuum is also a rough reticulum and continuum. For Poincaré, Dirichlet, mathematically. And then that was so that then with regards to even this is illustrated as well in asymptotic freedom of the quarkian and subatomic and sub constituent atomic elements that these mesons and leptons are made of, and bosons and fermions. That these are the kinds of things that help explain why it's possible to get back to a deconstructivist account, which is a little bit simpler and helps fill the detail of all these many kind of arguments and associate which ones are just due to these are the things that you can expect to find and will be true from mathematics. And then these other ones that say these are our limits we can achieve just because limits of reasoning, limits of time, or in accordance with the bookkeeping and the record keeping, or the gathering and collection of records over time, sampling, observer, and measurement effects. What results then these things to do with stochastic indeterminacy as just a matter of picking up the pieces. We had a cool game when we were children. So it's kind of like a colander, and with pieces of spaghetti in it, uncooked spaghetti, and then you put some marbles on that. The idea is then they make a nest of sort, and the marbles fit in it. And then as you remove piece by piece these are pieces of plastic and that would hold it up, then some of the elements would fall through as like a pachinko machine, or otherwise they would fall through. And the goal was to get the least. Vis-a-vis the hungry hippos, which is a very involved game and saw much use. We are therefore faced with a breakdown of our customary ideas about the indefinite analyzability of each process into various parts. Quasi-invariant, pseudo-differential, pseudo momentum. It's a good thing. Deconstructive analysis with a principled approach. Here are principles of least action, if not least surprise. These kinds of things. To deal with this new property of matter in the quantum realm, Bohr proposed to begin with a classical level which is immediately accessible to observation. So it seems. The various events which take place in this level can be adequately described with the aid of our customary general concepts involving definite analyzability. This is where it needs begot the mental sense of the number sense and the word sense, which we all have, of this object sense, then for the superclassical to entertain this notion for Zeno and his developments. We have a real infinity, and then with regards to these laws of large numbers, and like, is there a prime number or infinity or a composite? Maybe there's more than one. These kinds of things, vis-a-vis our expectations, and to show how these are the same expectations that we can build out from the small. So the Einstein's model physicist and Einstein's model philosopher are two different people, but the one can advise the other, and that is fine. Newton's laws. So this kind of gets back to is when we were reading from the Swanson's book on the path integral, how much goes into yes, it's just kept classical down here, and then we have our ordering, and it's our path. So it employs mathematics of continuum analysis. Will you please provide a foundations for Sam? Yeah, I will. Now comes the essential point. In order to give the classical laws a real experimental content, we must be able to determine the momenta and positions of all the relevant parts of the system of interest. So the position is as of rest at a moment, where the momenta are as of the propensity, their tendency as to change. Momentum is usually considered a conserved quantity, and after this sort of deconstructive analysis, it becomes a pseudo-momentum and conserved in the open. Such a determination requires that the system of interest be connected to an apparatus which yields some observable large-scale result that is definitely correlated to the state of the system of interest. But in order to satisfy the requirement that we must be able to know the state of the observed system by observing that of the large-scale apparatus, it must be possible, in principle at least, for us to distinguish between the two systems by means of a suitable conceptual analysis, even though they are connected in some kind of interaction. So this is hidden variables, whatever they may be. There's a saying in physics that quantum mechanics is never wrong. If it's wrong, you're doing it wrong. Quantum mechanics is never wrong. It's a continuum mechanics, and whatever it is defined by these hidden variables. So causality remains. even if we're much too slow to know all of it. Simple matter of resources. Consequently, one must regard what has previously been called the combined system as a single indivisible overall experimental situation. The above discussion of the meaning of a measurement then leads directly to an interpretation of the indeterminacy relationships of Heisenberg. As a simple analysis shows, the impossibility of theoretically defining two non-commuting observables by a single wave function is matched exactly and in full detail by the impossibility of the operation together of two overall setups that would permit the simultaneous experimental determination of these two variables. Now, one thing to keep in mind about Heisenberg uncertainty, position versus momentum. The more precisely you know one, the less precisely you know the other one. Is that's when you can't see what's going on, because when a particle hits the detector, it's exactly as it has gone through according to when it was from the emitter to the detector in that exact line by that exact time. Heisenberg's certainty principle. This is just a flip side of the necessary dialectic, the whole particle wave duality, to understand for this conceit of particles and waves why it's kind of like so. Both variables must therefore still be used together, but now they can be defined only within the limits set by Heisenberg's principle. As a result, such variables can no longer provide us with a definite, unique, and unambiguous concept of matter in the quantum domain. Only in the classical domain is such a concept an adequate approximation. He basically plans to explain this to something that doesn't think about it. Doesn't have to think about it. If there is no definite concept of matter in the quantum domain, what then is the meaning of quantum theory? It's mute. Moot. So this is a great book, and he really helps explore and explain the concepts of, the struggle to accommodate that there are these principles that are the absolute and utter fundamental bedrock of the idea that there's egalitarian or free and equivalent laws of the universe everywhere. Vis-a-vis that we're a dot. We're the whole dot. Oh, then he gets in some of the preliminaries necessary to understand quantization, which is normalization and denormalization, and what with regards to how we can go from the continuous to discrete in the physics of the day, and what mathematics owes physics, more so why that is so. So I've been reading this and I kind of enjoy it. This is a great little book. Blast power and ballistics, concepts of force and energy in the ancient world. So we have forces in our fields, and they're attached to these things, and there's energia, and we talked about dynamis and energia, the potential and the energy. And so Jack Lindsay is better or more famous or infamous. I'm not quite sure what to make of it. He's a British man, and most of his works are on the ancients and classics in terms of his scholarly works, and he wrote quite a biography of one of the French painters, or Courbet. And so I've looked into that a little bit. But this book is really great with regards to the antiquarian notions and development, because it really kind of covers a history and a timeline of the development over time of what are machines and weapons that go into then the theory over time, and as how it's developed, and what we retain and what's still true of that in these days that people need to kind of relearn, in the sense that besides what we have as the classical and the simple and the linear, for this tribological and rheological, that such kind of knowledge is still contained in all these earlier studies and the experiments and the ubiquitous success of the empirical in practical application of mechanical advantage and information advantage. Topology via logic. Now this is great. This is great because topology is missed in large, but this is for the continuum mechanics, and our usual open topology, which when you've studied enough mathematics, you'll have followed a course, and the definition of a topology and the nearness and density of points and the limit and critical points. So what this book does is establish this is kind of follows this from a usual book in topology called Counterexamples in Topology. This picks up the first counterexample that the usual open topology shows and shows how there's this whole other school that comes down off of it. So this is Vickers' topology via logic is pretty great, because it helps show that, yes, not only was it that your conscience was twinged when you thought about the rationals and irrationals being equal in terms of the properties, yet somehow one or the other picked for an opinion and held, therefore, into our standard good traditional linear curriculum after delta epsilon x of to triangle inequality, the stack of results, that someone at least has got this book published by Cambridge Tracks in Theoretical Computer Science that helps to explore the other side of the fence, which exists. A constraint model of space planning. Now this is from architecture, and so what this is related to is things like the backpack problem, knapsack problem. How many things can you fit in a volume? Like the isoparametric problem, isoparametric theorems. We have planning theorems with regards to the plan of things, which is usual notion of in a space, in a volume, a place for each thing, its place, its plan. So, this book is from the construction and the architecture of building, and so what it relates to also is like, here's how we can kind of elaborate and enumerate all the possibilities and combinations of things. Like here's what our sources would provide, and here's what our materials may be, and so here's given the site plan what we can do with the construction plan, and in terms of like, would you like to see all of those just kind of printed out? These kind of rules help establish how it's possible to do that. Or would you like this just moved a little bit to the left? Then what are you going to do about this other part right here? This helps explore all the theory that goes into making that a fait accompli, combinatorial enumeration largely. This is a great book. I really enjoy this. Astronomy and the Imagination by Norman Davidson. A new approach to man's experience of the stars. What he does is he helps describe particularly the concept of perspective and projection with regards to each of us in our view and the light cone of forward events. And we have what's called parallax, which helps determine via stereoscopic vision and the relative changes of things, the interpretation of effects in the three-dimensional. So we all live on Earth, and with regards to the horizon all the way around, we are small enough with respect to the Earth, and it's 25,000 miles across or around, and that and about that in terms of kilometers and miles. About that, from our perspective, we have a fundament, we have the ground. This is the alaya of the Dzogchens and this is as of a zero and a place of absolute firmament, right? Or as in with regards to the fundament is where we are and the firmament is up above. And so what he gets into is describing then, so first of all, what I get into is I got parallax, and then the peripheral parallax is on the sides. Like parallax and peripheral parallax reflect that this is the way the eyeballs, which are, though we have this whole projection onto the rods and cones of the retina, as for fixed perspective and fixed projection, how we have in our mental picture of things, eyeballs are round. And so they really get this kind of spherical information as with regards to what they gather and collimate. Right? So what this author does is he helps explain this whole concept of then when we look and notice things with respect to the horizon, and then when you look directly and straight up and notice things with respect to the sky, how that basically makes it so that instead of the peripheral being up and down, that the peripheral becomes forward and back. It's just a matter of perspective. And I hadn't really ever seen it kind of developed as a concept before. And so when I read this in this book, it's not about the imagination so much as about the theory and science. So this is a hard book, and it doesn't introduce anything that's, how about unicorns? How about chimerae? How about together? Are they the same? In theory, a fantastical theory. But what it is, it does help explain things to open the mind to imagination and its power rationally as well. The imagination is as important for the rational as it is for the creative. And the development of theory and the experience as well. A Beowulf cluster imagines this is an old phrase from one of the boards where it was kind of like that was a trope or a meme or a thing, because the idea was back in the days when computers were just start getting plugged directly into each other to operate in parallel. It was called a cluster, and one particular open source implementation was called the Beowulf cluster, named after Beowulf, the hero of Beowulf and Grendel, and this kind of thing. One of the legends of these things. The geocentric attitude to astronomy is admirably set forth at length in the introductory chapter to this book. As much as we're not flat earthers and we're not geocentric theorists in like our round Earth and heliocentric. At the same time, for the whole notion of the extension of objectivity and the observer effect, it is still the center. So that's nice. Others will be led to take a closer look at the sky than hitherto, and be enthralled by their discovery of how much more there is to see and notice than they had previously realized. Leslie White, FRAS, astronomy correspondent of the Daily Telegraph. So here's the acknowledgments, and he's got quite a bit. Public relations officer at the Royal Greenwich Observatory. Greenwich is, of course, probably most well known for Greenwich time. It's zero longitude, and so it's considered that the Earth is divided into 24 sections, and each one is as a particular hour and time, the difference according to the longitude. And so, thus is the day begins and ends in Greenwich, England, at the Greenwich Observatory. It's the same throughout the whole world, which today we call UTC or CUT, Universal Time Coordinate, UTC, or Zulu, and terrestrially and locally. Then with regards to the United States, it's provided by the naval station in Colorado's clock and network time. Why it's harder to find sundials these days, or mechanical clocks and such, and why it's been so important for devices on the network to be on network time and not just to avoid millisecond skew as of like timestamps of packets and such, is drift. Nowhere in print in English can I find a satisfactory publication on observational astronomy which treats it as a part of culture and as a creative science in itself. This kind of speaks to the fact that the Sky Survey is the most readily available observatory, and that we can remain passive in it. In addition, the theme has a relevance to many aspects of culture, including philosophy, psychology, history, literature, and mythology. Now, I feel bad that, well, I don't feel bad, but I note that the author observes the Cambridge comma, which is the lack thereof, of the Oxford Serial Standard and Harvard comma, which is deemed relevant and required. But as long as it's maintained comma in a style, then it's necessary to read for context vis-a-vis what otherwise also does include that the comma indicates a pause, and it is as of the most usual manner of speaking, the iterative list of comma-separated terms. So it seems to me that astronomy can relate like a mother study to all the sciences and to many other aspects of human life. So the author is quite profoundly affected by his study and his relationship with the firmament and the higher and the heavens in this sense. And so it said that it helps a lot when you're going to study the works of somebody or is through their lens according to their text, that they really have a claim to belief. Much is said and written today on cosmologies and star lore, past and present, legends, lore, mysteries, myths. Received wisdom because they couldn't write a comma. For this to be fully effective, it requires a firm foundation in the experience of the circling stars. The imagination of the title of this book must not be confused with any fanciful otherworldly treatment of the subject. Another author may use another word, but here it points to a vital and integral part of human consciousness, which is today too often ignored, and when it is, inevitably reasserts itself, but then it emerges as a distortion, leading to the realm of fancy, loose association, and mere invention. Thus, nature is not to be denied and takes its revenge, for we end up with mental creations which have no direct connection with the actual working of things. Then he quotes some poets and indicates that his descriptions will have such context. Not that inquiry into what the telescope and microscope show is unimportant. It is part of our modern experience in the science of matter. So anyways, yeah, this book then gets into a little bit later the effect of the sort of the horizon, about why it appears. You can always kind of estimate with let's say your thumb over the image of the moon, and it always fits. But the why it looks bigger and with regards to the optical illusion thereof is also as of an effect. So an effect of this sort. A good example is Ursus, which appears to grow smaller as it turns upwards from just above the horizon to being high above the pole. Something similar to this effect is produced by the stereographic method of projection. Right. Even quantitatively, the modern astronomer visualizes a sphere to position the stars upon before deriving everything else from it. For the stars in the first instance behave as if they were on a sphere and according to its laws. Celestial sphere remains the best star map. The Babylonians divided the celestial sphere into 3 parts. The north part is named Enlil, the middle part is named Anu, and the south part is named Ea. These were the 3 celestial ways. So anyways, then it goes on to introduce a bunch more terms from astronomy. Kind of like when it is read from Abel the other day, that it's a big deal. And it's kind of a static picture. So there's incredible amount of detail in it, and so there's always something to find. As to where is a good question. So let's see here then. Well, I hope this will be a good briefer talk for today. The shortest day of the year will have been December 23rd, the solstice, in the usual calendar and according to well understood events, and the Earth having its angle of 23.5 degrees with respect to its ecliptic, the plane, its orbit around the sun. Well, I shall so hope you have a great day, and we'll gather and collect some more later with regards to moment in motion. So then with regard to moment in motion, it's really keen to kind of try and figure out what are the things that will help to establish the sorts of simplest concepts necessary to reach an awareness at all, and a categorization, among other things, and a familiarity once of a continuum. So first it must involve the word and number sense. There must be a continuum of these things. There must be a universe of these things. Holism, monism, monadology, the absolute. Then as with regards to limits and uncertainty and chance, then it can help a lot to explain the roots of notions of indeterminacy, randomness, chance, uncertainty, with regards to what's given and what's expected, and what's expected and what's not expected, uncertainty. So then also we could point to Bayes and Jeffries and Knight as having different ideas about these things, and that they reflect different applications of what are various laws of large numbers. This also gets into things like whether various number theoretic conjectures are actually independent of the usual notion of the integers, like various Goldbach conjectures or Riemann hypothesis, and whether or not there's a standard model of integers at all, or there's only one without infinity and one with many infinities, called just a fragment or various extensions. There's no standard model of the integers. The continuum then is the concept that really relates all these things, and for Zeno it's profound, and for time and infinite divisibility it's profound. It's the absolute model of what is otherwise our perfect conceptions, perfect models of these things. So how to describe that above our senses first, because we need to accommodate everybody having inputs. And for a blind, deaf, insensate, anosmic person, they have to figure out how to, taste these things. With regards to a number sense, a word sense, and an object sense. It's kind of easier to manufacture an algorithm in words, according to numbers, as an object that has various ways to consider these things, vis-a-vis its inputs, that which is its world. So it's important to cultivate the understanding of what that is, and why thinking arises from that. To then reach this continuum, to then get to where this isn't so much necessary for the linear curriculum. It's not necessary for the standard curriculum and for all such sorts of things as usual, especially when the models are simple, effective, direct, and fine. We don't need any more than that. One measure is enough. but use it twice. Measure twice, cut once, the usual terms. But getting into the notions of the continuum, and then this real the reality of the hidden variables is kind of this concept of what needs to be cultivated because it's learned. It's and so for some people, if it's not given as a course, then when they encounter it in their thinkings, they'll just assign it to otherwise usual notions of the absolute or the heart or the intuition, that which is whole, that which is the universal. And so these various concepts and they get into it make for that. It's all part of the canon already. Now we have kind of divide between the epistemological as arriving from the teleological, that nowadays is kind of the ontological, that what was our teleological that was having too much baggage was left behind. But it still has this essence, the essential property of what it is, what is true. It's truth. So then, with regards to that, it is possible for then these notions that go from the classical, and as Bohm illustrates so continuously in his declarations, and much as for the imagination in the realm of association, and with things like Werkheimer's association that truth is paramount and a real thing for his phi and the Gestalt, and Kant's sublime and the Gestalt of more than its parts, more than its fragments, all of its parts. That these are the kinds of things that end up making it so that it's also possible to provide a sort of enrichment in a curriculum to help what otherwise is the matter of pulling together all these hundreds of works in the canon and deriving what are these common threads that so relate things vis-a-vis our apparatus, formal apparatus. So that said, there's plenty that can be gained from so little, and then that essentially, as long as it still results that there's a free consistency, an infra-consistency, between, intra, among, infra, both, infra-consistency, that this is the kind of the desiderata and requirements of for Heraclitus's Hilbert's. Heraclitus is, there's dualistic monism. It's infra-consistent. And Hilbert's is like, there is a mathematics. Do we have one yet? Yeah. And with regards to and not to be underdone. It's full, and it's also sublime. What I'll hope to get back to a little bit more are the path integral and the Fourier-style analysis. This is a book by Gonzalez Velasco, and it's called Fourier Analysis and Boundary Value Problems. And after the first few chapters, which has been read here, kind of, and development of heat equation and Scholler, then he's getting into more of the stuff that goes on into what is a fuller sort of derivation and a surrounds and the theory of the things, which then make for this notions of, as Einstein says, my theory, when it's going to be a total theory, is a differential system also. That it comes back together again in this way, while still having what's so provided, proviso, all what's so relevant, the accommodations of our limits, and the profound relation of the relative, as we are kind of relative to each other, and the absolute of which we are all relative. Hey, have a great day, if you so will.